Hi everybody and welcome back. Today we're going to be talking about Unit 3, Lesson 5, which is derivatives of inverse trig functions. So in our previous lesson, we talked about finding the derivative of any inverse function, and today we're going to talk specifically about inverse trig functions, which are some of the most common inverse functions that we come across mathematically. Our target for today is I can use the chain rule with the definition of an inverse function, or the formula for the derivative of an inverse function to find the derivative of an inverse trig function. We are going to focus today on learning the formulas for the derivatives of inverse trig functions. So what I'm going to do right now is kind of just lay out the 6 derivatives of inverse trig functions that you need to know, and then we will go through some example problems. So let's start with the derivative of inverse sine. So the derivative of inverse sine would be 1 over the square root of 1 minus x squared. And the nice thing about inverse trig functions is that the follow-up here, which I'm going to show you, is the derivative of inverse cosine. The derivative of inverse cosine would just be negative 1 over the square root of 1 minus x squared. So I think about those two as almost like partners. They're the exact same thing, except for the cosine is negative. The derivative of inverse secant would be 1 over the absolute value of x times the square root of x squared minus 1. And the derivative of inverse cosecant would be the same exact thing, but just negative. So negative 1 over the absolute value of x times the square root of x squared minus 1. Last but not least, the derivative of inverse tangent would just be 1 over 1 plus x squared. And you guessed it, the derivative of inverse cotangent is the exact same thing, but just negative. So negative 1 over 1 plus x squared. Now, I know that these formulas seem very complicated, and I know when I first learned them, they seemed a little bit overwhelming. Please don't panic. The more that you use them, the more that you have to go back and refer to them, the easier they're going to be to remember. The one thing that I do want to remind you is that we can't forget chain rule. So, for example, if you ever have a problem that says inverse sine of 3x, because the x is a 3x this time instead of just an x, you would need to use chain rule when you're doing this problem. We are going to do some examples like that together today, so just kind of keep an eye out for those and make sure that you understand how we're applying chain rule combined with inverse trig derivatives. So let's try problem number 1. Problem number 1 is about as straightforward as it gets. So if I want to find the first derivative here, this is just a do you know the rule question. And the derivative of inverse sine would just be 1 over the square root of 1 minus x squared. The derivative of inverse tangent would again just be, pretty straightforward, 1 over 1 plus x squared. So just learning the rules. Now let's look at some problems that are actually a little bit more interesting because they have chain rule. So in problem number 3, what you're going to notice is that the outside function is inverse sine, but the inside function is x cubed. So when I find the derivative here, so y prime, I'm going to start with the outside function. Now the derivative of inverse sine says 1 over the square root of 1 minus whatever was inside there. So sometimes that's x squared, sometimes it's not, squared. Now, what in this problem, the inside stuff is just x cubed. So the only thing that's different is instead of just x squared, it's x cubed squared because we have x cubed inside of our inverse sine function instead of just an x. Then chain rule says you take the derivative of the inside. In this case, the derivative of the inside would be 3x squared. What we can do now is simplify just a little bit. So instead of 1 on the top, 1 times 3x squared would be 3x squared on the top. And on the bottom, we would have the square root of 1 minus x cubed squared would be x to the 6th. Kind of just simplify a little bit. All right, let's try one with inverse secant, which we haven't seen yet. So let's try this. Again, we have an outside function, which is the inverse secant, and we have an inside function, which is the 2x. What that means is in this formula, everywhere that there used to be an x, it's going to be a 2x now. And then we're going to have to use the chain rule. So the derivative of inverse secant says that we do 1 over the absolute value of whatever's inside there times the square root of whatever's inside there squared minus 1. In this case, the thing that's inside there is the 2x. And then we need to multiply by the chain, which in this case would just be 2, because the derivative of 2x would just be 2. Now again, we're going to simplify. So on the top, I'm going to multiply the 1 times the 2, and I'm going to get 2 on the top. And then we're going to talk a little bit about how you simplify an absolute value. An absolute value says take whatever's inside here and make it positive. Since the 2 is already positive, it doesn't need to stay inside of the absolute value anymore. So we can actually move that out to the front and then just leave the x inside of the absolute value. Then we have the square root of 2x times 2x is 4x squared minus 1. Last but not least, we can simplify. So the 2 and the 2 simplify because 2 divided by 2 makes 1, which means we get 1 over the absolute value of x times the square root of 4x squared minus 1. And that would be your final answer. Let's take a look at a couple more examples. So for number 5, we've got inverse sine of the square root of 2t. Now, that means the outside function is the inverse sine, and the inside function is the square root of 2t. So y prime would equal, the derivative of the inverse sine is 1 over the square root of 1 minus the stuff squared. So in this case, the stuff is the square root of 2 times t. Now, the chain rule here would be the derivative of the square root of 2 times t, which is just the square root of 2. Now, if we simplify, on the top, we're going to have this 1 times the square root of 2, which is just the square root of 2, all over the square root of 1 minus the square root of 2t times the square root of 2t would just be 2t squared. And that would be your final answer. For problem number 6, we have a problem with inverse cosine. So the outside function here is inverse cosine. The inside function here is 3 over t squared. So the derivative of inverse cosine is very similar to the derivative of inverse sine. It would just be the negative version of that. So negative 1 over the square root of 1 minus whatever the stuff is squared. In this case, the stuff is 3 over t squared. Now, we need to multiply by the chain rule. And in order to do that, I think it's easier to rewrite this as 3t to the negative 2 power. So the chain rule here would be negative 6t to the negative 3 power. Now, simplifying this one's going to be a little bit trickier because we've got these fractions and negative exponents. So let's go through this one step at a time. First, I'm just going to rewrite this with a fraction instead of a negative exponent. And I'm going to simplify this first fraction a little bit as well. So I'm going to have negative 1 over the square root of 1 minus, now 3t squared 3 over t squared would be 9 over t to the 4th. And again, this is all underneath the square root here, times, and then I would have negative 6 over t cubed. I'm just rewriting that with a fraction instead of a negative exponent. Now I'm going to kind of multiply these fractions together. So I'm going to have 6 over t cubed times the square root of 1 minus 9 over t to the fourth. And then, because it looks kind of messy with kind of this fraction inside of a fraction, I'm going to make common denominators. So I'm going to have 6 over t cubed square root of. Instead of 1, I'm going to think about this as t to the fourth over t to the fourth. So I'm going to have t to the fourth power minus 9 over t to the fourth power. That's my common denominator. And since this is a square root, it can actually get applied to the top and the bottom separately. Now, I'm not going to apply it to the top because that doesn't simplify, but this becomes 6 over t cubed square root of t to the fourth minus 9 over the square root of t to the fourth would be t squared. So by kind of distributing that square root, I was able to simplify that. And here's why that's helpful and beneficial. T cubed and t squared are going to simplify. 2 of the t's are going to cancel, and there's only going to be 1 left. So my final answer here would be 6 over t times the square root of t to the fourth minus 9. Now, that's a lot of algebra-ing. But you have to agree that this final answer looks a lot simpler than what we originally started with. So it's worth it because we get a nice simplified answer. For problem number 7, we're going to be working with inverse cotangent. Now, in this case, the outside function is inverse cotangent, and the inside function is the square root of 1 minus t. The derivative of inverse cotangent says to do 1 over, over 1 plus the stuff squared. In this case, the stuff is 1 minus square root of 1 minus t. And then we need to multiply by the derivative of the stuff. Now, I think it's easier to find this derivative if we rewrite this as 1 minus t to the 1/2 power. So times 1/2, and then 1 minus t to the negative 1/2 power. And then here's where it gets really tricky. Because this is negative t, we have to multiply by -1 as like a third chain. Now we need to simplify. So the nice thing about square roots and squareds is that they cancel, which means this first fraction just becomes -1 over 1 plus 1 minus t. Now I'm going to multiply the -1 times the 1/2, so I get -1 over 2. And because this is a negative exponent, I'm just going to move that to the bottom. 1 minus t to the 1/2 power. Last but not least, I'm going to simplify. So 1 plus 1 is 2. -1 times -1 is 1 over 2 minus t is the first fraction, times 2, and then a 1/2 power is really a square root. And then just to make it look a little bit nicer, I'm going to go ahead and move the 2 to the front. All right, one last problem. Let's say that y is equal to inverse tangent. So y prime would be the derivative of inverse tangent, which is 1 over 1 plus the stuff squared. In this case, the stuff is the square root of x squared minus 1. Then we need to multiply by the derivative of the stuff. I think it's easier to do that if we rewrite this with a 1/2 power. So I would have times 1/2, and then x squared minus 1 to the negative 1/2 power, times 2x. So the chain, because the derivative of x squared is 2x. Next, I'm going to simplify. So square roots and squareds undo each other. They're inverse operations, which means I just have 1 plus x squared minus 1. Now, this negative power is going to go to the denominator, and this 2 is going to cancel this 2. So I'm going to have x, which is left over on the top, over parentheses x squared minus 1 to the positive 1/2 power. 1 minus 1 is 0, so 1 times x gives me x in the numerator, x squared in the denominator, and I'm going to rewrite this as a square root. Now, because we have an x in the numerator and we have an x in the denominator, one of these x's is going to reduce, and we can divide both by x. So I have 1 over x square root of x squared minus 1. All right. Thank you guys so much for watching, and I will see you in class for some practice.